This short lecture introduces the measuring of precipitation, most commonly rainfall, at a location or point in the landscape. Measuring point rainfall. One may simply think of rainfall depth as the real depth of a layer of water on a flat, impermeable surface after rainfall. A low-budget way to make a simple collector-type non-recording rain gauge or pluviometer for measuring the rainfall depth is to buy a plastic bottle in a shop, drink or dispose of the bottle's contents, cut the top from the bottle at about 2/3 of the height of the bottle, turn the top around, and attach the turned over top to the lower 2/3 of the bottle, as shown in this figure. The top of the bottle acts as an orifice opening that catches rainfall, and the lower part as a cylindrical container where rainfall is stored. Finally, dig a small hole in the ground and tightly fit the bottom of this rain gauge into the hole. To determine the rainfall depth, proceed as follows. Determine the radius of the orifice in centimeters. The radius is half the diameter, and determine the surface area of catch of the orifice in square centimeters. This area equals pi times the square of the radius, with pi being 3.141, etc. Empty the bottle after a rainfall event or at fixed time intervals, and measure the volume of rainfall in cubic centimeters, which, by the way, is the same as milliliters. Simply divide the volume of rainfall in cubic centimeters by the surface of catch of the orifice in square centimeters and multiply this result by 10 to obtain the rainfall depth in millimeters. There are three main types of recording rain gauges for measuring precipitation at the point location. The weighing rain gauge to the left, the float and siphon rain gauge in the middle, and the tipping bucket rain gauge. In a weighing rain gauge to the left here, the mass of the water in the gauge is continuously measured and registered. Since 1 liter of water has a mass of 1 kilogram, any difference in mass can easily be converted to a difference in rainfall volume and thus rainfall depth. In a float and siphon rain gauge, the depth of the water in the cylindrical water collector is continuously measured and registered using a float resting on the water. A siphon empties the water once the water has reached its maximum height. And this corresponds to the position of the bending end of the siphon. In this way, rainfall depths and intensities can be determined. In a tipping bucket rain gauge, the bucket tips over each time a certain volume of rain has fallen, usually corresponding to a 0.2 millimeter rainfall depth. By registering the timing of the tips, the average rainfall intensity each time the bucket tips, as well as rainfall depths over longer periods of time, can be determined. It is probably useful to mention a number of the problems that one can encounter when measuring precipitation. When placing a rain gauge in the field, one should take care to ensure that the rain gauge is well exposed. For instance, that the distance from a high object is sufficiently far as not to be measuring in the high object's rain shadow. The rain gauge is an obstacle to wind causing turbulence, and as a consequence, raindrops may be blown out of the orifice, leading to an underestimation of the rainfall depth. The higher the orifice, the larger the wind speed, plus the smaller the water droplets, the more pronounced the undercatch of the rain gauge will be. To prevent underestimation of the rainfall depth, it is best to measure rainfall depth in a ground level rain gauge as shown here, where the top of the rain gauge is placed at ground level at the center of a grid network and brush or empty space that prevents the splashing of raindrops from the ground into the gauge's orifice. Another reason may be that a hydrologist usually wants to know the rainfall depth entering the soil rather than the rainfall depth at some standard height above the ground.